Welcome the new student for grade 8. Today we'll start with lesson 1 in unit 1 called Attempts of Elements Classification. Attempts of Elements Classification. What's meant by attempts? Attempts meaning trying, the scientist trying to organize the element in table. That was discovered later. We had a study in grade 7 that the number of elements that discovered till now 118 elements. These elements are found in the Earth's crust. The scientists discovered them and divided them into groups, put them in table. After separating them from the Earth's crust, they study their properties to compare between them. We know that we have two types of properties, physical and chemical properties. Physical properties meaning the element, its color, its shape, its texture, what is the point that has melting, changing to liquid, or what is the freezing point, the point that has changed to solid, what is the boiling point, it's the density, it's float or sink in water. This is all of them, it's called physical properties. And also have chemical properties. Chemical properties meaning how it reacts with other elements or react with oxygen in the air or the water vapor. This is called chemical properties. Each element have physical and chemical properties, and they are maybe similar in some elements and maybe different in some elements, but not all the properties are similar in two elements. Each element have its own properties. They are physical or chemical. So after they are discovering the element, they must order or organize them in tables to facilitate their study, to using them later in any chemical reaction. In chemical reaction is very important in our life. We use them in manufacture or making anything around us, like plastic, anything human made is happened by chemical reaction. And this chemical reaction will needing to react the element. So we must discover their properties. So we organize in table to facilitate their study and find relation between their physical and chemical properties. What is the similar, what is the different in properties. And we have three types of attempts. Three types of trying the scientist to organize the element in table. The first one called Mendeleev periodic table. Mendeleev periodic table, according to the name of the scientist that designed this table. Second one called Moseley periodic table, according to the name of the scientist that trying to study this, design this table. The last one called modern periodic table. This is have many number of scientists. Not one have designed this table, so it's called the modern periodic table, and this is the last table that we use today in our life. So we have three types of attempts: Mendeleev, Moseley, and the modern periodic table. We will talk about the first one called the Mendeleev periodic table. Mendeleev was a Russian scientist, have many discovering in chemistry, and he collecting his discovering in book called The Principle of Chemistry in 1871. And in his time, the number of elements that was discovered was 67. In his time, the number of elements discovered 67, not as today we have found 118 elements. And Mendeleev, how he designed his table. He tell us how he designed his table. He prepared cards, the number of elements that was discovered in his time. So he prepared 67 cards. And each card put in each card the element, the symbol of element that we have studied later in grade 7. Each element has symbol, and it's two number beside the element. We have two number beside the element. the atomic number and the atomic weight. Atomic weight, we study the atomic weight, the number plusing the number of proton and neutron. And the atomic number is the number of proton only. So besides the element, symbol, atomic weight, the sum of proton and neutron, and property. Its chemical or physical property. So each element, beside its label, to tell us what is this element, have name, symbol, atomic weight, and physical or chemical properties. What is the melting or boiling or density, color, how it reacts with oxygen. And we know the table must have column and arrow, like this table. We have columns and row. Each table has column, vertical column like this, and have horizontal row. He putting in the same vertical column the element that has similar properties. So he putting in the vertical column the element that's similar in properties and call this column letter is group. And putting the element in period it's horizontal row. So he prepared 67 card, putting name of element and its symbol, atomic weight, and arrange the element that has similar property in vertical column and call this later as a group. And putting the element according to ascending order. He's starting from the left to the right. From the left to the right. He putting the element according ascending order from the smallest atomic weight to the largest atomic weight from the left to the right in horizontal row and call them our period like that. He putting the same properties element in group and putting the element according to ascending order in atomic weight. Yes, from the left to the right, increasing from the smallest atomic weight to the largest atomic weight in each horizontal row, and call this row later is a period. So we have group and period. In each table have group and period. And arrange the group to two subgroups. So he divided the group to two only, A and B, because they are found. They are different in properties. So he put the group, the element that has similar properties in group A, and the other element that has similar properties but different in group A in B. So he divided the element into subgroup A and B, and each group have different properties from each other, but in group A similar in properties, and element in group B similar in properties. And after that, he, after putting the table in period and group, he realized that each new period, the element properties repeat periodically. So the first one in the first row have the similar properties in the first one and the third row, like that. He found the first element in period number 1 have the same properties of the first element in the row number 2 or the period number 2. And they are also in the third period has the same properties. So I found that element in each beginning of new period, its properties repeated periodically. So we call it periodic table. So we know that why it's called periodic table, because we found Mendeleev that properties of the elements repeated beginning of each new period. This is what Mendeleev do. He gave prepared 76 cards, 67 cards, and putting in them the symbol, the atomic weight of the element, its properties beside the element, and arrange them in groups, vertical and horizontal periods, and divided the group to two groups only, A and B. A and B are different in properties, and he found the properties of the element repeated periodically, reaching a new period. But after he designed the table, the scientist after him found he has advantage and disadvantage. Something correct about his table, and something is doesn't correct and must be corrected. The good thing that or the advantage judgment do, he found after organize the element according to ascending order atomic weight from the left to the right, he found that the element doesn't organize orderly. For an example, he discovered the element that has atomic weight 11, and after that there is no found atomic weight 12 or 13 or 15 or 16. We found 17. So between 11 and 17, the scientist doesn't discover this element in his time. So he putting 11 and 17 after 17 after 11 and doesn't left the space. No, he put 11 that was discovered and let empty space for the element that between 11 and 17 and putting 17 in his place. So he left space for gaps for the element that doesn't found in his time. So he predicts that this element is found, but not one had discovered them later, and give to them to it space or empty cell, okay, and putting the element as a correct order. So the advantage, the first advantage, he predicted discovery new element because he found the element, all the element that has organized number doesn't, some of them doesn't discovered in his time. So left gap or empty cell or empty card to it and putting them in order correctly order. The second advantage of Mendeleev, he correct the atomic weight that was wrong. Some element scientists before Mendeleev discovered the element and putting atomic weight to it, but he found the scientist putting atomic weight to some element was wrong. So he corrected the wrong atomic weight of some element that discovered before him. This is the two advantage. So the two advantage or the good thing about Mendeleev periodic table, he predict the discovery of new element, putting space or left gap in the table. He corrected the atomic weight for some element that was wrong. But what is the disadvantage or the wrong thing about Mendeleev's periodic table? Number one, we have two disadvantage. We have also two disadvantage. Number one, as we know, we divide the element to subgroup A and B, and putting the same properties in A and the same properties that different in A in T. So they are putting the element that's similar in properties, even they are not order organized correctly. Like what? He found that element that had atomic weight 12, similar in properties in 20, similar in properties in 30, similar in properties in 35. So he putting them in T in one group. So he putting the element that has same properties in one group, even they are not organized order well in the number. So he has disturbance in ascending order of atomic weight of some elements. So putting them in the group that suits their properties. So he make disturbance in the order of the element. The element order must be organized good from 1 to 67. The order must be right from 1 to 67. But he put the element that same probability in one group, even they are not organized orderly well in the number. The second disadvantage of Mendeleev, he had to deal with isotopes. Isotopes is the same element. We know the element, like hydrogen, have a copy of it. Each element have copy for it. Maybe two, maybe three, like hydrogen. The original hydrogen is the first one. Have one atomic number, have one atomic, but its isotopes, it's two. So each element has its copy of this element, but different in something. So the isotope is a copy of the element, maybe two or three or four or one copy. These isotopes are similar in the original element in atomic number, but different in atomic weight, different in the number of proton plus nitrogen. So the isotopes, they are found the scientists that properties of isotopes different from the original elements, and we must not deal with them as same elements. But Mendeleev doesn't do some wrong. He deal with the isotopes as one element. He see the isotopes of hydrogen and the original hydrogen, all of them is one element and the same element, but they are different in properties. But he deal with them as one element, which were discovered later due to difference in atomic. So he deal with the isotopes of the element which were discovered later as different element. Scientists after him discovered is a different element because they are different in atomic weight. But he deal with it as one element. But we must deal with it as different element because they are different in atomic weight. There are the two disadvantage of Mendeleev. So the disadvantage of Mendeleev is two disadvantage. We make disturbance in the order of in the atomic weight of elements to put them in group that suit or similar their properties. We deal with the isotopes as one element, but is discovered later is a different element because they are different in atomic weight. And he make other mistakes. He put the iron and cobalt and nickel elements in one cell, in one card, in one gap. This is wrong because they are different in properties. And maybe it's have shiny or luster or it's a metal, but they are different in some properties. So we must not deal with them as one element or putting them in one card. They must have three gaps or three cards. But he deal with it or putting them in one cell. That is wrong because he found they are similar in properties, but not similar in all properties. We must put them in different cards. This is the disadvantage of Mendeleev. Again, we talk about Mendeleev. He is Russian scientist. Discover in his time was the number of elements that discovered 67 elements. He put his discovery in a book called Principle of Chemistry. He prepared 67 cards. Put in each card its label, have its symbol, atomic weight, physical or chemical properties, and divided them to two subgroups A and B because they are different in properties, putting them in vertical column called this later is a group, and arrange the element ascending from the smallest the atomic weight to the largest atomic weight from the left to the right, and call this period. And he found the properties of the element repeated each new periodical. So we called it periodic table. He have two advantage or good thing about Mendeleev table. He discovered that element doesn't organize correctly because some element doesn't, all the element doesn't discover. So he predict discover new element and give its empty gap and predict its atomic weight. He corrects the wrongly atomic weight that's discovered before him. And the three advantage of Mendeleev, he make a disturbance of ascending order of atomic weight of some elements to put them in group that suit or similar to their properties. He deal with some isotopes as one element that will discover later after him it's different because they are different in atomic weight. He put more than element in same cell like iron, cobalt, and nickel because they are similar to him in their properties. This was all about Mendeleev periodic table. The second attempt is about Moseley periodic table. Moseley, the scientist, New Zealand, discovered something important about the atom. He discovered the nucleus of the atom. We study in grade 7 that the atom consists of positive nucleus in the center and around it negatively electrons revolve around the nucleus. He discovered that the atom contains nucleus in the center and it's charged positive. This is Wolseley. This is Rutherford that discovered. Rutherford discovered that the atom has nucleus positively charged in its center. This is New Zealand's Rutherford scientist discovered it. But Moseley studied the Mendeleev periodic table and add to Mendeleev periodic table correctly something about Mendeleev periodic table. Moseley arranged the element in period ascending like Mendeleev, but not as atomic weight according to atomic number. So Mendeleev arranged the atomic number of element ascending from the smallest to the largest according to atomic weight, but Moseley arranged the elements according to atomic number from the smallest atomic number to the largest atomic number. Ascending. See the difference between Moseley and Mendeleev. Atomic number, the number of protons only. Atomic weight, the number of protons plus the number of neutrons. This is something different, Moseley periodic from Mendeleev. And he discovered some properties of the element by X-ray. X-ray is type of ray. The scientists used it to discover the shape of the element or atom and how it's react physical or chemical properties. So X-ray, we know that we used in someone break his bone. So it gives a picture about the broken bone. But the scientists also used it in discover some type of properties of elements. And the Moseley doing that. And found the atomic number, it's related to the properties, not the atomic weight. So the atomic number related to the properties, not the atomic. So the correct thing about Moseley, he arranged the elements according to atomic number, not atomic weight. And how he designed his table. He also make a group and table, a group and period. He also Moseley designed the table as groups and periods. But he arranged the elements in the same group, ascending in atomic number. This has atomic number 3, 4, 5, 6, 7. So he arranged the element in a period ascending order according to atomic number. And putting in the right side of the table 0 group. Okay, so Moseley arrange the element ascending in period according to atomic number, not atomic weight like Mendeleev. and each element increased by one atomic number than the before or preceding element. So he arranges the element ascending order according to atomic number, where the each element increase than the preceding or the before him. Each element increase the element that before him or preceding element by one atomic number of. So as we see, lithium, beryllium 4, beryllium increasing the preceding or before element before him lithium by one atomic number, and boron increase in atomic number by one from the preceding or the element before him, beryllium, that was 4, and so on. Each element increase from the preceding or the element before him by one atomic number only. And he had two groups to the table. In the last left side, he putting group called zero group, and it's include inert gas. Include inert gas, as we see. So mostly design the table as groups and periods. Each element increase than the preceding element before him by atomic number by number 1, and the element ascending order from the left to the right in the same period, ascending order to atomic number. And he add two groups, zero group in the right side called inert gas, and putting two periods below the table called lanthanide and actinide. Again, mostly design the table as a group and period. Design the period, the atomic number increased by one from the preceding element, and arrange the element ascending according to atomic number, not atomic weight. He adds zero group in the last right side of the table. This is the inert or the noble gases. We will talk about it later. And putting below the table two periods called lanthanide and actinide. Lanthanide and actinide. This is what mostly putting in his table. That is was mostly putting in his table. So Rutherford discovered the atom has a positively nucleus inside its center. Mostly arrange the element in period according to atomic number, and using X-ray to predict his study. Putting zero group in the last right side of the table, and discover lanthanide and actinide, and putting them below the table in two periods. The last attempts modern periodic table. In modern periodic table, there are many scientists sharing in this design table. But one of them is called Bohr. Bohr was a Danish scientist. We study that the atom has a nucleus in the center. Around it mean 7 the energy level. We study the energy level mean R7 KLMNOPQ. There are the main energy level around the nucleus that electron revolve around the nucleus in them. So the Bohr scientist that discovered the main energy level was 7 in the heaviest atom till now. After that, after Bohr, the scientists come and discover there are not also main energy level. In each main energy level, there are sub-energy levels. So Bohr discovered the 7 main energy levels. Scientists after him come and discover They are for each main energy level, there are sub energy levels. There are sub energy level for K, sub energy level for L, sub energy level for M. Sub energy level are have energy inside the main energy level. There are sub energy level inside the main each energy level. In the modern periodic table, the element also designed in table and group like this. This is called the modern periodic table. This is called the modern periodic table. This is the shape of the modern periodic table that we use today in our life. It has also group, vertical, and horizontal row. And horizontal row. It also, in period, the scientist order ascending order to the element according to atomic number, like molecule. So in modern periodic table, the element order by ascending in atomic number, not atomic. And it has 7 periods and 18 groups. 7 periods and 18 groups. And the scientists in the modern periodic table order the element according to atomic number and have sub-energy level filled with electrons. So the modern periodic table, the scientists arrange the element ascending according to something, according to atomic number, how the sub-energy level filled with electrons. So they are arranged the element by 2 ways. How it's arranged by atomic number, or how element, electron in this element fill the sub-energy level. And they are found each main energy level has the same number of sub-energy levels. So K is the first one, has main energy level, first one. So it has one sub-energy level. Second one, L, has 2 sub-levels. The third has 3 sub-levels. So each main has the same number of sub-energy levels. And we know that each element, the element that's covered till now 118. 92 are discovered in the Earth's crust, the rocks of the Earth. But the remaining are artificial prepared. The scientists prepared the remaining of 92. So 118, all the number of elements discovered. 92 found in nature. Allah made them in rocks found in the earth crust. But the remaining of 92 is artificial. The scientists made them. So this is our the lesson for today. We studying the attempt trying the elements to classify or arrange the element in table to facilitate their study and to make a relation or compare between its physical or chemical properties. We had 3 attempts, mainly periodic table, mostly periodic table, the modern periodic table. Mainly arrange the elements in period according to atomic weight. Mostly arrange the elements ascending in period according to atomic number. Modern periodic table arrange the elements in period ascending atomic number and how the electron filled the sub-energy level. Mainly, the number of elements is 67. He made chord. He arranged the elements in 2 subgroups A and B. He predicted the discovery of new element and putting name to them left or space or empty card. He corrected the wrongly atomic weight that was before him wrongly. He had disadvantage that he deal with the isotopes as one element. He make a disturbance in ascending order of elements. He putting iron and cobalt and nickel in one cell. mostly arrange the elements in period according to atomic number. We add zero group in the right side of the table, putting two periods below the table, lanthanide and actinide. Modern periodic table, the last periodic table that we use today in our life, that has 118 elements, 92 natural found in the Earth's crust, and the remaining are artificial developed. That was the lesson for the day. We will complete the lesson in next session. Good luck.